we have NOT gate and then NAND gate. So I told you guys earlier that for every logic gate there is an electronic symbol. Okay, so for the NOT gate we have its symbol in this form. So this is a NOT gate. So if here is A and I have C here, I would have my input here to be A and my output to be C. So for every NOT gate, we have only one input and then we have one output. Okay, so what happens is that the NOT gate always provides the opposite of whatever is at the input. So if I have negative at the input, it ends up providing positive at the output. So for example, if I have the input to be 1, I would have here as my output to be 0. If I have the input to be 0, I would have my output to be 1. Okay, so this all about the NOT gate. It converts a positive input to a negative output and vice versa. Okay, so we could also have 0, I'm sorry, let me try with 1. Yes, so if I have 1 here, I still have 0. Okay, and if I have 0 here, I still have my 1 here. So that's all for the NOT gate. Okay, it just gives you the opposite of what you've inserted. That is it. All right, so let's get to the NAND gate. NAND gate. So let's get to NAND gate. NAND. So for NAND gate, as we see here, the NAND gate is a combination of two gates, okay, which is the AND gate and the NOT gate. So one thing that you should take note of is that the NAND gate is made of two gates, which is the AND gate and the NOT gate. So this is the symbol for the AND gate as we did in the previous video. AND gate with this here and with that there. And then we have a symbol for the NOT gate, which is that. So the combination of AND gate and then the NOT gate gives us what we call NAND gate. So it means if I connect, you see we always have this here. So if I connect this side to what is here, I have a NAND gate. Okay, I have a NAND gate. So this is an example of a NAND gate. I can also represent that in this form as well. I can also have this here. Yes. So this is like a triangle with some lines coming from both sides. Okay. So this is a NAND gate, but mostly some books use this simple symbol. Some books use this simple symbol here. Yes. So there's this small circle here, and then the line comes after it. So this is also NAND gate. So we have the NAND gate with this symbol attached to the AND gate, and then we have the NAND gate with this small symbol attached to it. Now we learned earlier that for every AND gate, okay, for every AND gate, both sides should be positive so that we have a positive output. So let's get back to the same thing that we did in the previous video. So if I have, okay, my input A here, yes, A here, and then my C here. So I'll have A here, my C will be here, and let's say the output here would be D. So D is my output. Now, if A is 0, I can have C to be 1. Okay, I told you this 0, 0, 1, 0, 1. So if A is 0, I could have C to be 1. If I still have A, you let me go to 1 before I come out to the same 0. So if A is 1, I could have C to be 0. So let's say we are just alternating 0, 1, 1, 0. And then I could also have A to be another 1 with C being 1. And I could also have A being 0 and then C being another 0. Let's see. For every AND gate, so let's say the output, let me divide the output into 2. Let me do it this way before I get back to that. So for every AND gate, I would have 0 here, 0 here, 1 here, another 0 here. I told you all should be 1 to give me one output. But here's the case that we have a NOT gate which is fixed here. Okay, so this means that the NOT gate will produce the opposite of the results from the AND gate. So instead of the AND gate having the input of 0, 1, giving us 0, it will rather give us 1. It will rather give us 1 because there is a NOT gate attached to it. So when a NOT gate is attached to the AND gate, it converts the output of the AND gate to the opposite. So 0, 1 supposed to be 0 for AND gate, but the NOT gate will change the 0 towards 1. The same thing applies here. We still have our 1 here because 1 and 0 is supposed to give us 1, but the NOT gate will change the 1 to 0. So we have 1 1. So 1 1 means for AND gate you should have 1 as the output. So 1 will be at the output, but NOT gate will change that 1 to 0. Then we have our 0 here. Then we have 0 0, which is supposed to be 0 for AND gate, but the NOT gate attached will convert the 0 to 1. So you have 1 here. Then we are done with the truth table for NAND gate. So you have to sit down and revise all this. So the NOT gate here convert every single output of the AND gate to the opposite answer. Okay, so 0 1 supposed to give us 0 at the output, but NOT gate will convert that 0 to 1 because we learned that the NOT gate does the opposite. Okay, so let me hear from you guys. If you don't understand anything here, just comment and we will address every issue.